Hey friends, welcome to follow up. Let's have a look at problem 92, reverse linked list 2. This is today's daily challenge problem. So in this video, we're going to give you a digest so that you can further modify the code. So here we are given the head of a singly linked list and two integers, left and right, where left is less than or equal to right. So we want to reverse the nodes of the list from position left to position right and return the reversed list. So here notice that the indexing is one indexing, in other words starting from 1. For example, this is the node 1, this is node 2, this is node 3, and so on. So in example 1, so we want to reverse this part. So the part we are going to reverse has head 2 and the tail 4, right? So the tail will be the new head and the head will be the new tail, right? Then we connect them together. So in example 2, the left and the right are actually the same. So in other words, so there's no reverse actually in action. The constraints are the following. First, the number of nodes in the list is n, which is bounded in between 1 and 500. So it basically says that the list is not null and it's not very long, right? So, and the node value is in between negative 500 and positive 500. So left and right are in bound, and left is less than or equal to right. In other words, they are consistent. So with that said, basically we are going to write the code, and in between we are going to explain the logic. So the natural thought will be the following, right? So we need to locate this head and also the previous one, that is 1. And also we need to locate the tail and the follow-up one, right? Because we want to connect the previous one, here is 1, to the tail, and then connect the original head to the 5 here, right? So this will be our main logic. So let's first write some utility function or hyperfunction to do this. So notice that the problem has a follow-up which said, could we do it in one pass? I guess after this explanation, so doing one pass will be very straightforward with a little bit effort. So the first hyperfunction I'm going to write is reverse linked list, right? So after we locate this part, we need to be able to reverse that. So here we isolate this part and write as a hyperfunction. So we're going to have a head of a linked list, right? Then we want to reverse that. This is actually very standard. Let's use a null, right? So call it previous, and the current val head, right? So if head is null, so it actually does not enter the while loop. We directly return the previous one, right? While head, what should we do? So we want to reverse the pointers, right? So first, let's save the new head. The new head will be the head next, right? And then after we do this, we can set head next equals previous. So this line of code actually does two things. First, so we actually break the connection of head and head next, and then we set the head next to be the previous, right? And then we are going to update, right? So previous will be the current head, and head will be because we have already set previous head next to be previous, but we also save this one, so this head will be the new head, right? In other words, the head next before we do this line of code. So afterwards, we just need to return the previous, right? So this is very standard. So let's maybe print out one just to verify this is correct. So reverse linked list. So let's accept the height. So let's run the test. So this for 5, it will going to give this one. This is right. Let's also use the first example to test. So 2 and 4. Right, so if we reverse the whole list 1, 2, 3, 4, 5, we're going to get 5, 4, 3, 2, 1. So things works. So now with this done, so let's comment out this part. So what we are going to do is to locate this one, in other words, the node before the left and the node after the left, and also we get this one, and then do the reverse. So first I'm going to save the original height because we want to return this one, and then in between I got dummy 1 and dummy 2. So it's going to be now and the very beginning, and the reverse height, so it's also going to be now. So we want to set them. So let's write here maybe. So put another none here. So now basically let's do the while loop. So we have a previous, so previous equals dummy 1. Let's set this, and the count is 0. The count is counting the index of the previous, right? So previous we set index as 0. So the height will be starting from 1, right? While height, or what we want to do. So first we check if count equals left minus 1. It means this is the previous node we want to locate. For example, in example 1, this will be 1, right? So in this case, we are going to set dummy 1 equals previous, and then so if we are able to set this one, then the corresponding height will have index left. It's going to be the height for the list, for the part of list to be reversed. Let's do it like reverse height to be the height, the current state of height. So this is the first check. Another check is if count equals right. If count equals right, means that the previous will be this number 4, right? And then the height, current height, will correspond to this 5. So what we are going to do is to so first, because previous pointing to this one, we are going to set previous next to be now. In other words, we break this link, and also we want to set dummy 2 to be the current height. So up to this stage, we can break, right? So we get all the information we need. So dummy 1 corresponding to the 1 here, dummy 2 corresponding to the 5 here, and the reverse height corresponding to the 2 here, right? So now let's update this while loop. So previous we will update to height, and height to be height next, right? So in between we need to do the count, increment the count by 1. Notice that each time we move one step further, so the count is incremented by 1. This is in natural logic, right? So with that done, so let's print out something for, let's see, dummy 1. Let's also print out dummy 2. So let me use 2 and 2. And also let's do reverse height. Let's print f reverse height. It's going to be reverse height, right? So another part I want to print is that I want to print the reversed reverse height. So as in this problem, it's going to be 4, right? So let's call this function. So we are going to apply this function to reverse height, right? So here we are missing a parenthesis. So now let's, before we do further work, let's do a test. For example, dummy 1 will be this one, right? Corresponding to the original list in this example. And dummy 2 corresponds to 5, right? And onwards. and the reverse height will be 2, 3, 4, right? That's 2, 3, 4, and after we reverse, it's going to be 4, 3, 2, right? So we are going to comment out this part, and then let's see if we have the right indentation. So now what we are going to do is to do the work, right? We connect this part with 1 with 4, 2 with 5. But it's possible, like in example 2, the dummy 1 is null, right? So we want to do a check. So first let's do reversed height. That's going to be this one. So we apply this reverse function to the reverse height. So we're going to reverse this part, right? So, and let me maybe delete this part. So this way it will be automatically indented. So now if dummy 1, in other words, it's not null. So in this case, we're going to set dummy 1 next to be the reversed height. So then we want to find the tail of reversed height, and then do the same. So tail actually is nothing but the original reverse height, right? So basically what we can do, so we can add one more variable if we like. So for example, reverse height, original reverse height. So let's also set it to be null. So original reverse height. So then afterwards, reverse height to be this one, original reverse also to set to this one, and then we're good to go. So so we get this one, or we feel like, so we can do a for loop. Maybe this is more intuitive. So what we want to do is that, so we set a previous to be reverse height, and current to be reversed height next. So due to the problem assumption, this reversed height is not null at the very beginning, right? So then we do a simple while loop. So so while current, and then we just need to move the pointer previous to be current, and the current to be current next. So this is very simple, right? So thus we exit this while loop, the current will be null, while the previous will be the tail of the reversed list. In other words, 2 here. So then we just need to connect the current next to be dummy 2, the 5 here, right? Then we prepare the return. So first, if left does not equal to 1. So in this case, we just need to return the original height after this work. So this is also the purpose here. So we return original height. Otherwise, what we want to return. So because in this case, we just need to for example, we started from 1 and reversed up to 4. So we just need to return the reversed height. So let's see, reversed height. So this will be the full logic of this problem. The code runs a little bit long, but the logic is very simple, right? Just continue writing the logic out. So let's first do a test. Non-tab have no in current next. So so here it's not current, it's previous. So let's do a test. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that said, basically that's about it for this video. As we mentioned, we didn't make an effort to write in one pass, but with this logic here, it's actually straightforward to write in one pass, right? So that's about it for this video. Thank you.